Okay, here are the solutions to the quiz that you wrote earlier today. A couple of very basic limits that you had to evaluate. Before I go over this, I just want to remind you of some things in terms of working with limits and notation. Every time you rewrite the expression by manipulating it somehow, by either factoring or rationalizing, and you rewrite the result, you need to continue writing limit in this first question as x approaches -3. So if you completed this quiz and you didn't write limit all the way through, I took off 1 mark and you ended up with 5 out of 6. Another point is when you're working at this level in math, you should always be working top to bottom. From the top of the page, you do some work and then you write your next step below that and below that and below that. You do not want to be writing left to right and writing equals, equals, equals in a left to right fashion. If you get to the bottom of your workspace and you have no more room to go, then simply from that last line that you've written things in, draw an arrow up to the top of the next column of your workspace and continue your work there. The first thing you want to do with either of these limits, of course, is see what happens when you substitute the value that the variable is approaching in for the variable in the argument or the function you're taking the limit of. So when we try to put -3 in for x, we would get -3 quantity cubed plus 27 over, in brackets, -3 squared minus 9. Remember what you've been taught in the past, and I've mentioned a couple times already in this course, I believe. When you substitute a number in for a variable, always put that number in its own set of brackets. When you work out what this is, -3 quantity cubed is -27 plus 27 is 0 over -3 squared is 9 minus 9 is 0. So you get that 0 over 0 form. And what this is telling you is that the limit most likely exists. What you need to do as a student is use your algebraic skills, which would include factoring and rationalizing, to change this function so that you can put in -3. Well, we write the limit as x approaches -3. X cubed plus 27 is a sum of cubes. A sum of cubes, a cubed plus b cubed, factors into a plus b, and then a squared minus ab plus b squared. When I apply that to x cubed plus 3 cubed, because 27 is 3 cubed, I'm going to get x plus 3. I'm also going to have x squared minus x times 3, which we would write as minus 3x, and then plus 3 squared, which is plus 9. And this is, of course, over x squared minus 9, which factors as a difference of squares into x plus 3, x minus 3. You can see you have a factor of x plus 3 in the numerator and denominator, so they cancel. Now, it's at this point in time you can go ahead and put -3 in, and most of you did, but if you are going to rewrite the simplified form of this expression and write x squared minus 3x plus 9 over x minus 3, since you still haven't loaded the -3 into the expression, you need to write the limit as x approaches -3 of this expression. The brackets are not necessary. However, it's at this point in time that you can put -3 in. -3 quantity squared minus 3 times -3 plus 9 is what happens on the top. What's going on the bottom is we have -3 minus 3. On the top, you end up with 9 plus 9 plus 9, which is 27. On the bottom, you have -6. And what's interesting at this level is many of you just put that as the answer. And that's fine. I'm not going to take off marks for this. But you get so caught up in the calculus and the algebra that you forget to ask yourself if this simplifies. And this, in fact, simplifies to -9 over 2. So if you just do this, that's fine. You get full marks. If you want to write it as a limit statement at the end, as I said earlier, you cannot just write this equals -9 over 2. What you need to write instead is that the limit as x approaches negative 3 of x cubed plus 27 over x squared minus 9 is equal to negative 9 over 2. The next question, if you put h equals 0 in, just as an exploration, you're going to get 2 minus root 4 plus 0 over 0. 4 plus 0 is 4. When I take the square root of 4, I get 2. 2 minus 2 is 0. So I end up with 0 over 0 here, which means I'm in the same boat that I was in question 1. And that boat is one where I have to use factoring and rationalizing in order to simplify this expression so that I can put h equals 0 in. I'm going to rewrite this limit, the limit as h approaches 0 of 2 minus root 4 plus h over h, and multiply both the numerator and the denominator of this expression by 2 plus root 4 plus h, which is the conjugate of the numerator. I don't think this really needs to be emphasized, but I'll say it anyway. The reason why we're doing this is there's nothing else you could do. You have to try something. You're not just going to stand there and look at the problem. You're going to take a step forward mathematically, and the only thing that's possible is rationalizing. This becomes the limit as h approaches 0, and I'm going to have in the denominator an h, and then as well as the factor of h, I'm going to have a factor of 2 plus root 4 plus h. In the numerator, now I'm going to write out what we get in the numerator with an intermediate step. You probably don't need to write this, but I'm going to point out to you that when you take two binomial conjugates, that's what these two things are. This and this are both binomials and they're conjugates. And you multiply them together, you get the square of the first term minus the square of the second term. So that's what we do. And again, I don't think a lot of us need to write that. Many of us would have just written here the limit as h approaches 0 of 4 minus 4 plus h over the factor of h and the factor of 2 plus root 4 plus h. Now, if you wrote this, you lost a mark. And the reason you lost a mark is because if you wrote that, your algebra would be wrong, because we have to subtract the entirety of 4 plus h. So if you didn't put brackets there, which led to an incorrect answer, then you lost 1 mark, and you ended up getting most likely 5 out of 6 on the quiz, which is 83%. The next step would be to simplify this even further, and this is the limit as h approaches 0 of, well, 4 minus 4 is nothing, and you're left with an h, and then we have, as well as h in the numerator, we have a factor of h in the denominator, and 2 plus root 4 plus h. Now, even if you wrote that set of brackets, some of you ended up putting h here, and that's wrong. What you should have is negative h. So I'll tell you right now that if you didn't put the negative, you lost half a mark. And most people that didn't put the negative, that was the only place they made a mistake on the quiz. And when you lose half a mark out of 6, I believe that leaves you with 92. So if you ignore the green writing in this video on this screen, what's written in brown would be wrong at both stages. Anyway, the next step now is to recognize that I'm going to rewrite this as negative 1h, just to highlight the point that the only reason you can cancel the h's here is because h is a factor in the numerator and the denominator. And now what we're left with is the limit. As h approaches 0, we have negative 1 on the top and 2 plus root 4 plus h on the bottom. Now I'm going to put h equals 0 in. And as a student, maybe I've hit the end of my workspace here. So again, don't go equals and just keep writing stuff left to right. What you should do is that, and continue at the top of the next column. It's at this point in time I'm putting in h equals 0, so I no longer need to write the limit notation. It's going to be negative 1 over 2 plus the square root of 4 plus 0. I'm changing h to 0. 4 plus 0 is 4, so I'm left with negative 1 over 2 plus root 4. Root 4 is 2. I'm left with negative 1 over 2 plus 2. So my answer is negative 1 over 4. And again, if you want to write it as a summary with the limit, then you need to write the limit as h approaches 0 of that whole function. You need to write it down is equal to negative 1/4. But anyway, that's the answer to the second quiz question. And for those of you that didn't quite get 100% on it, I hope that that helps out and you understand where your mistakes were. Overall, I was very, very happy with how well you did. You guys did excellent. We'll talk to you later.